try to say true things. I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. Just pray you'd help us as we prepare for the test tomorrow, just to settle any questions that remain, and just whatever we do, Lord, it will be for your glory, Lord. In your name I pray. Amen. So, first of all, I have some bad news and I have some good news. The bad news is that the grader did not spot the 3 grievous and sizable errors in my solution, which would then suggest that he took off points from some of you unjustly. And unfortunately, I have not had time to sort through who lost points without justice and who lost points with justice. So the simple solution for me would be to add 6 points. So I will be adding 6 points to your quiz.
Thank you.
Yes. So if you had a 4, you now have a 10. If you had a 20, you have now a 26. If you had a 22, you will now have a 28. I don't know what the scores range over, but I'm guessing that no one has 22 because I'm pretty sure the grader counted it wrong even if you're right. The question is, which problems were those? Well, we'll get to them. So let's go through the quiz, and then I'll take questions past it. I think the quiz is a good place to start, as it has questions that are, well, these questions certainly would not be surprising if they were similar to questions which are actually on the exam. However, I did tell you something in the syllabus early on. What did I say about exams as they relate to homework? I said 50% of the questions on the test will be very similar to homework. Now, I guess it could be argued that that's already the case with this, so maybe that's not a meaningful, but I will look through the homework and make sure I'm not missing something. I didn't have a chance to do that for the quiz, so I should maybe mention that to you. It might not feel that way, though. There's a lot on this quiz, right? First of all, to find the interval of convergence and radius of a convergence, do you guys have any questions about what I did here? Yeah.
Interval of convergence, radius. Oh my gosh, radius of convergence. I'm fuzzy on what makes it different.
The interval is an interval. The radius is just a number. So like interval is a subset. It's a collection of real numbers. It's a set. The radius is just the length of the set divided by 2, if you will. So like the length of this set is 4 minus 2, which is 2, right? So that means its radius is 1.
That's it?
Yeah. If the set's the whole real line, then the radius is infinity. Because infinity divided by 2 is still infinity. No, it's not really the real reason, but yeah. So, yeah. So the logic here is I'm looking at the ratio, of course, of the terms in the series, and it works out to the 2k plus 1 over 2k plus 3 times the absolute value of x minus 3. As the k goes to infinity, this piece goes to 1, that piece goes to the absolute value of x minus 3. So in order to have the ratio of the absolute value, well, the absolute value of the ratio of the coefficients limiting to less than 1, it requires that the absolute value of x minus 3 be less than 1, which is to say that x is between 2 and 4. Then, that just tells me about the so-called the open interval of convergence, right? I don't know what happens at the endpoints unless I study further. So if I plug in 2, which is the left endpoint, that gives me this alternating series, right, with terms which go to 0. So this is convergent. And the other hand, this one is divergent because it's kind of like half of the terms in the p series, right? So I know that I can do limit comparison to p equals 1, and that'll work out for me. You notice if I take 1 over k plus 1 divided by 1 over 2k plus 1, I get this, which goes to 2. The reason I did 1 over k plus 1 is because my series starts at 0. So I kind of need the slightly modified p equals 1 series to be most natural. Anyway, you know, if you didn't have all of this and you just told me that this is essentially a harmonic series and it diverges, I wouldn't have taken off a point. That is the kind of intuition I want you to be gaining. But anyway, you do need to think about the endpoints for these problems, right? Unless what? Unless I say find the open interval of convergence. If I tell you just find the open interval of convergence, that means you don't care about the endpoints. Whatever happens, happens there. And you notice that once you find the open interval of convergence, which here is 2 to 4 right here, this is the open interval of convergence, you can already tell what the radius of convergence is there, right? The radius of convergence is not influenced by what happens at the endpoints, okay? So, not usually anyway. Problem 2. So here I apparently forgot to do some erasing. That is supposed to be whited out. Oh well. I don't know what that is. It's a hanging Chad in my mind or something. I don't know. What do we got here? So this is x over, I factored the 3 out. Then this is geometric series, provided what? The ratio x cubed over 3 is less than 1. And then, of course, to solve that, we need that the absolute value of x is less than the cube root of 3. And so that's where my interval of convergence comes from here. You notice I don't need ratio test or anything to find the IOC because this is a geometric series. And the geometric series result tells me the interval of convergence directly. All right? So in my mind, there are 3 sort of easy ways, there's 3 dominant modes to find intervals of convergence. The first and most unexciting one is you use the ratio test and check endpoints. The second is it's just straight up a geometric series. So geometric series comes with a radius of convergence if you study the details. The third, and this is the laziest, is that what you're given is a known function, like sine, cosine, or whatever, perhaps composed with like the square function. So something like sine of x squared, I can tell you the interval of convergence for that when I find the power series for it is at the whole reals. Like the power series for sine, cosine, cosh, sinh, exponential, these have radiuses of convergence of infinity. They're what are called entire functions. Of the standard list of things you're supposed to know, there's some that are not entire. There's some that don't have radius of convergence of infinity, like the log one, it's not that way. And also binomial series, it doesn't work for all x. Binomial series stops working. I think binomial series is only good, I think like -1 to 1. And whether or not -1 or 1 gets included is a complicated story depending on the power. So I don't remember off the top of my head. Oh, any questions about this one? Okay. Well, you guys just interrupt if you got something to say. This one here is use geometric series techniques to find power series for inverse tangent of 7x cubed. So I differentiate, it gives me that. A geometric series, this thing, it gives me this lovely thing, and then I have to do algebra to work out that this is the power series for it. Once I have the power series formulation, then I can integrate term by term. Doing such gives me this. And then I notice that f of 0 is inverse tangent of 0, which is also 0. So that tells me my constant is 0, and there you go. Of course, this answer is kind of ugly. It's kind of pretty if you can reformulate it that way, right? Because that's really 7 to the 2n plus 1, and there's a -1 to the n. And this 21, it's got 3 times 7, so the 3 in there cancels with the 3 down here to leave you 7 to the odd power divided by same odd number times -1 to the n. This is a pretty formula. It's kind of nice. Now, I probably would not take off points if you left your answer like that on the test, but I might give you a bonus point if you did that, you know. This, number 4, is one of the places I had an error in the solution. So my initial solution had not this, it didn't have -11 here, it had something else, I forget, it doesn't really matter. The point of this is, if we have that the function diverges at 5, right? Its center is where? Looking at this, I can tell the center is -3, right? So that tells me that if you get 8 units away from the center, because from -3 to 5, that's 8, right? 5 minus a -3 gives me 8. So there's distance 8 from here to here. Then anything beyond that has to be divergent on either side. because of the way the domains for power series work, right? They're always intervals symmetric about the center. So if I diverge 8 units this way, I also have to diverge 8 units that way and beyond. Okay? You can't have that it converges in here and then all of a sudden 300 units over there, there's a little spot of convergence. Like, that is not how it works, thankfully. It's much simpler than that. So once I know that that's divergent, I know that anything beyond -6 is also divergent, because that's 8. Excuse me, that's, what am I saying? Oh, you guys are confused. Did I? What have I done? Oh, I'm talking about the second picture and looking at the first. I'm an idiot. This is for the largest interval of convergence. I got to think about points of divergence, because if I want it as large as possible, I can't get rid of the fact that 5 diverges, right? So beyond 5, I have to remove, and to the left of -11, I have to remove. Those are necessarily points of divergence, since I'm given that it diverges at 5. So the largest is -11 to 5. If 5 diverges, that doesn't force -11 to diverge, right? So I can include that. That's the largest possible with the given data. Question?
That actually you just answered.
Oh, okay.
What test would you use here to test whether or not -11 diverges or converges?
You can't. There's not enough information.
Then why is that a bar that says that it converges?
Because that's the largest possible in view of the information which is given.
Oh, so that's if you don't know whether it diverges or converges, it converges?
No, I'm saying in the hypothetical universe of all possible examples, and I'm just given this data that it converges at 0 and diverges at 5. It's possible that it converges at -11.
Oh, and it's larger to converge
It's-
at -11.
Yeah, it's
diverge at
possible that it diverges, right?
That makes sense.
I mean, for all I know, it diverges at 4, right? But there exists the possibility it doesn't, so I want the largest possible in the absence of more information. The smallest is forced upon us by the convergence. See, if it converges at 0, that means it has to converge everywhere closer than 0. So if -3 is the center and it converges at 0, it has to converge everywhere on the way to the center. But then it's symmetric, so it also has to converge 3 units the other way, because it's always plus or minus the radius of convergence from the center. And then, since I'm looking for the smallest, I exclude the point which I don't know. Make sense? So, what's the point of this problem? The point of this problem is to try to get you to think about the theorem we had on day 1, which is, what does the domain of a power series look like, right? So this is just kind of a sideways way of asking you a question, which tries to really probe your understanding of that theorem. First 3 terms, non-trivial terms in the power series centered at 0. For this function, I personally thought that binomial series is the way to go here. You could differentiate 7 times and plug in 0 and figure out that only the first, the fourth, and the 7th derivative are non-zero, if you wanted to. But I think that probably my solution's better, right? I mean, so this is x times 1 minus x cubed to the minus 1/2 power. But I own this thing, right? This is 1 plus u to the minus 1/2, making a u equals minus x cubed substitution, right? I really should have written over here u equals minus x cubed. That would improve my solution. It'd be good if you wrote that. But my solution, there are a few things missing in it. I was looking at it with you guys this morning. I noticed a few things. I tried to add those where I noticed, but anyway, so there's the first 3 terms in the binomial series, right? And so k is minus 1/2, so that ends up giving me 1/2 and 3/8 because the minus and the u combines, right? Any questions? So if you don't know the binomial series, this problem is really hard, right? So that's definitely a tool that you'd like to have in your toolbox. This one here, I made a differentiation mistake in my first solution, which you can see from the oddly placed whiteout spot and the x squared plus 1 sine x down here. So I originally, I think I just had, I forget what I had, but I had something else here, and it led me astray. To me, the fastest way here is actually just to use the Taylor's series directly. You could play the adding 0 game here and see how it worked out for you. I don't know which is faster. I think this is faster, because differentiating 3 times isn't that bad. Anyway, so when I plug in 1, I get 2 times sine of 1. That gives me this first term here. This is supposedly f prime of 1. So the derivative is, by the product rule, 2x sine x. Hey. Oh, wait a minute. Derivative of sine is cosine. Phew. My brain is messing with me. So you notice when I plug in 1 into this, I get 2 sine 1 plus 2 cosine 1, which gives me this coefficient down here. F prime prime, I got product rule again. All right. And when I plug in, that's a minus. So when you plug in 1, you get 2 sine 1 here, you get 2 sine 1 there. 2 minus 2 is 0. It just leaves you with the 2 cosine 1, actually, plus 2 cosine 1, which gives us 4 cosine 1. So the coefficient over here should actually be, I mean, if you could simplify this, right? The coefficient should be twice cosine 1 times x minus 1 squared. Again, sorry about the mistake there. And sorry that the grader did not realize. This just has too many problems for me to fix here, so I just put it on the next page. We'll get back to this one. I'll tell you what was wrong with my solution before I go on, though. I neglected to distribute this minus. Very bad, very, very bad. That minus goes through here. And also, I failed to do the arithmetic here correctly, because I should have had, given my other mistake, this should have worked out to not 3/4, but, I changed it, didn't I? This is actually right, 3/4, but I had something else there before.
It was 9/4.
Yeah, and if that was 3/4, that would make that 1/4. But again, this is all subject to an error up here. Let me stop talking about it until I get to the solution that's correct. Okay, so shut up. Problem 8. This, everyone here who takes the test should do this problem, like a problem like this. You should welcome it. You should embrace it. You should realize these are points for the taken. It requires very little thinking. Well, it does require one thing. You need to know the power series for sine, right? But if you know that, and you understand the substitution principle, right, which you just plug in 7x cubed in the place of the variable for sine, then all you got to do is just algebra. We can all do algebra. 3 times 2n plus 1 is 6n plus 1. But I'm multiplying by, it's 6n plus 3. Can't do math. And then I multiply by x, so that's 6n plus 4. Then these other coefficients, they're minding their business out here. Whatever they're doing, they're doing. Integrate. Gives you that. Answer. Done. In fact, if you think back on all that time we spent on different integration techniques, it's kind of annoying. Because we could have just always converted everything to a series and integrated term by term. We could do everything that way. Why don't we do that? Yeah. Why? Because what? No, I mean, that's what I did here, is integrated term by term. Why didn't I do that? Why did we go to the trouble of partial fractions and integration by parts and all that other stuff earlier?
Converting back to an elementary function might often be difficult.
Right, yeah, that's the thing, is you cannot convert this back to an elementary function. Well, I can't. Is it possible? In other words, is this a product? Is this like sine of something times maybe x squared or things like that? That's actually a really difficult question to answer. Is this power series a power series which represents a known elementary function? Elementary functions are those functions that are built from sine, cosine, exponential, cosh, algebraic functions, things like this. There's a more technical definition. And if you give the more technical definition, there is in fact a theory which has been developed which will you can feed this formula to a certain theorem, and if it satisfies a certain criteria, then it's possible to rewrite it in terms of elementary functions, and if it doesn't, you can't. There is mathematics which does this, but it is not calculus 2. And I mean, it's beyond any course we offer here. But that's the kind of math which is behind like Mathematica and other things of that nature. Here's the corrected problem 7. So to find the power series of x squared divided by 1 minus e to the 3x. So the 1's cancel in the power series, right? So this up here, I forgot to write it on this page, but we had x squared, right, over 1 minus e to the 3x. So that's equal to x squared over 1 minus parentheses 1 plus 3x plus 1/2 times 3x squared plus dot 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 dot, right? And so you see what happens there. The 1's cancel, right? And you're just left with these terms. So how do we find a power series for something like this? Long division, I think, is pretty much, well, actually, I think it's the only way, honestly. This problem forces long division on you, essentially. I'm not sure that was my initial intent, but it is an outcome, whether intended or not. So here it is. To get the minus 3x, to get x squared, I have to multiply minus 1/3 x times minus 3x. The minus 3 and the minus third cancel, give me back an x squared. That's my starting point. And then I have to multiply minus 1/3 times that, which gives me 3/2, and that gives me 3/2. I take the difference, then I get minus 3/2 x cubed minus 3/2 x to the 4th. Then the question is, how can I eradicate this thing by taking a product of this with something? Well, that something is 1/2 x squared. So because 1/2 x squared times that gives me minus 3/2 x cubed. Then when you take the difference, those go away. When you take the difference of these two things, be careful, that's actually 6/4 minus a minus 9/4. I learned my lesson in my error. So I'm much happier about this. This is 15/4, which seems so much more interesting than my previous wrong answer of 1/4 or 3/4. I mean, 15/4. You gotta. I mean, that's a much better number, right? I'm just talking. Anyway, so 15/4. Then the question is, how do I get 15/4 from this? Well, I mean, I would have to multiply this times minus 5/4. That would give me a minus 15/4. Excuse me, that would give me a plus 15/4, which would cancel that out, right? So there you go. That's the first 3 terms in the power series expansion for this function. I was not trying to make this problem super tricky. I just inadvertently did. All right. Sorry about that. I was not like I don't like sit down and plot against you. Like, how can I make the problem extra tricky? I know if I make a minus 3 appear there, that'll really rain on your parade. But it did, right? This would have been so much easier if this had worked out to like x, right? So how could we make this problem easier for ourselves? How about this? If at the start of all of this, if you just factor out minus 1/3, the calculation would have been so much easier, right? So just a bit of advice. If I somehow accidentally do something mean to you like this, be wary, all right? Be ready to factor out a minus 1/3 to make your life easy, right? Do one annoying arithmetic step rather than 30 of them, all right? Now, I thought, well, I'm going to check my answer. All right, so I tried to check my answer. So I go, I'm finding the Maclaurin series. I plug in 0, right? But what? It says 0 over 1 minus e to the 0 is 0 over 0. What? And f prime of, oh man, this got 0 over 0. What? Ah, curses. So actually, technically, this function is not defined at 0, right? So what's meant when someone writes something like that? Now, I don't think the reason anybody lost points in this problem was because of this. But the truth is, I really should have written this. This is the true definition of the function. It's defined to be 0 at 0, right? And otherwise, it's x squared over 1 minus 3x. That would be the better thing to write here. And all I'm really saying, and the reason I know that 0 at 0 is because the reduced function, all right? When I cancel the x, see I've got an x squared up here, I've got x everywhere down here. So if we divide the top and the bottom by x, I get that. This is well defined at 0. If I plug in 0, I get 0. I get 0 over minus 3, which is 0. Okay. So anyway, I will try to be a good citizen of the mathematical world. And on the test, if I was asked this question or one like it, I will write the function like so. But you should be aware that there are these creatures called engineers and authors of engineering textbooks. And those kinds of creatures are very likely to just write this and not this, right? Some of you have asked me, what does this mean as it regards certain homework exercises, right? So in my heart, I know that if I'd written this, it wouldn't have changed anything for you guys on the quiz, actually. If you missed this problem, it's because of something else, right? I'm speculating, but that's what I do. I think, so approximate this guy to within an error of that guy, 0.00001 by an appropriate application of the alternating series estimation theorem. So what you want to do in a problem like this is to replace your integrand with a power series approximation, keep a couple terms. You got to have some kind of number sense as to how many terms you need to keep, right? I look at this, I go x to the 19th over 19, and then I'm going to evaluate it at 0.5. This is pretty sweet. Like that's stupidly small. That's definitely going to be more than I need. So I can stop there. This would be a good error term. That kind of on the bubble. 0.5 to the 7th is like, it's around a millionth. I'm not sure how that's going to work out. Now, when you actually work this out, that ends up being 3 over 448, which is 0.06696, which is not negligible. I mean, it's too big to ignore, right? I mean, that is bigger than my precision I'm looking for. So I should not ignore this term, you know? You can, if you take more, I can't really count you wrong, right? Unless I include other words like use the smallest approximation to be within a certain tolerance or something, but that would require more writing on my part, and it would be more likely that confuse you with the wording, and that would just be probably bad on my part to do that. So now I was hopeful that this would be smaller. See, if this was actually, if I had said 0.01 for the error, what could you have given as the answer? 0, right. The answer is 0 to within 0.01. Any questions? Yeah.
Why did you write 3.6 times 10 to the -6 above the answer?
The error is at most 3.6 times 10 to the -6. That is the value of this guy. So 0.5 to the 19th power times 36/19 works out to 3.6 times 10 to the -6, I think. Unless I made a calculator mistake, which is possible. Yeah. Yep.
So would the answer for this just be the first term?
Yep. Yep. Problem 10. Problem 10, you know, if you just go calculating and you don't know what you're doing, if you don't have some kind of simplifying guidelines in place, this is a very horrible problem. But there's some very simplifying assumptions observations you can make. First of all, if I'm looking for the 100th derivative, that means I'm looking for the coefficient of x to the 100, right? Which is an even term. So this is an odd function because this is even times odd, which is odd. Therefore, this first monstrosity cannot produce an x to the 100. I can ignore it. This cosine x to the fourth, well, that's a little bit more troubling. That's at least even. So I'm kind of a little bit worried. But if you look at that, the details of it, it goes from the 96th power to the 104th power. So that actually also does not contribute anything to the 100th power of x coefficient. In fact, the only term here which can produce an x to the 100 in the power series expansion is this last guy, which is just straight geometric, like so. And so if you look at it, you need 2n equal to 100, n equals to 50. It doesn't really matter. All of the coefficients are 1, right? It wouldn't matter if n was 700. It would still have a coefficient of 1. In fact, you can see, well, I might shut up. So basically, the coefficient of x to the 100, after we think about it for a little bit, is just 1. So 1 is equal to f to the 100, 0 divided by 100 factorial by Taylor's theorem, which tells me that the 100th derivative is in fact 100 factorial. Yeah.
What do you mean when you said that we can have n equal to however big of a number and it'll still be, the coefficient will still be 1?
Because this, I mean, what I'm talking about is that this piece of it. I mean, if I was dealing with something other than 100, then it would matter. I'd have to start facing contributions from the other terms. But as long as I'm even and I'm not one of 8, 16, 24, 32, 40, 48, those multiples of 8, right? I mean, this also contributes terms like that. But here's the power series for it. It's rather boring. This is really relaxing. I'm enjoying this. I guess I should stop, though. I mean, my point is, all of the coefficients of this series are 1.
Okay.
Now, and so if I asked what the derivative was, you know, so like this one, there's no other way to get an x squared term, right? Because you notice the cosine x to the fourth skips from 1 to the 8th. So this one too, these two are in isolation. If I think about the power series for f, those are the only two terms that contribute to order 2 and order 6. So I can tell you without further calculation, f prime prime of 0 is 2 factorial. I can tell you that the 6th derivative of 0 is 6 factorial. Also, same line of thinking. In fact, I can tell you the nth derivative is n factorial for those n which are even and don't fit into the cosine series. Because the coefficients are all 1. Very boring. I've worked problems where the coefficient wasn't 1, right? We actually had to. Number 11, I think, is difficult, but I hope you've done enough homework that you're starting to get to the point where maybe you have a shot at it. So basically here we add and subtract 1 to create x minus 1s. So this x squared gives me the first 3 terms. At this point, I know that up to quadratic order is special. It's going to not match a general pattern, and the general pattern has to take over at like n equals to 3 or something like that. Only when I get to cubic and higher order am I going to have some sort of regular pattern from the other terms. So what I want to do is I want to split off the constant, the linear, the quadratic. Those are special pieces. And so that's what I'm doing here, is I'm making algebraic steps to accomplish that goal. And I also know that there's going to be an even piece and an odd piece. And I know that the cosines are going into the even. And I know that the cosh is going into the even. I know that the sinh is odd. So it's going to go into the odd. So that's why I'm making these steps here. 2 things, right? To expand an x minus 1, but also to identify which is even, which is odd, because those are going to get grouped. And so here's all the oddball terms, so to speak, the ones that are not part of the bigger pattern. Well, that's part of it. Excuse me, yeah, this is it, up to order 3. And then order 3 and higher, well, these are what's down here. So up to order 3, I've got these constant terms, which is this one, that cosine 1. There's an e over here. That's it, right? That's the constant term. The linear terms, I've got a 2 here. I've got a sine of 1 here with a minus. I've got an e over here, so there's those. The quadratic terms, I've got a 1 from that. I've got a minus 1/2 cosine 1 from here, and I've got a minus e over 2 from that one, right? And then this term right here is coming from the power series for that. This term right here is coming from the power series for that. This is coming from the power series for the sine, and this is coming from the power series for the sinh. But that's it.
I don't yet see how you do how to swap the first three terms. Like, well, why are they oddball terms? I don't immediately see that.
Well, because this x squared plus this x squared is not part of the general pattern in these two functions. So x squared is the third thing in the power series because you got 0, 1, and 2.
Okay.
So that was my thinking. It's conceivable that x squared could somehow so conspire to give you terms which fit into some general formula. But I give up hope on that to start with. Yeah.
Is it like a similar problem?
A similar problem.
Less than, some other number?
Well, I mean, I could. I guess we can.
Or at least like the geometric power series.
Here, how about this one? Let's try x cubed plus x to the 10th times the cosine of 3x plus the sine of 7x. There we go. I'll keep it relatively simple because we don't have a super long time. Like if I actually do one of the ones where we have to add and subtract 1, those take longer. But I think this will accomplish several goals, one of which was showing Josh an example of reindexing. So this got that. This got it in there. All right, yeah. This is good. Let's find the power series centered at 0 for this one. This is a little bit easier than problem 11, but it's kind of in the same ballpark. All right? In other words, find the Maclaurin series, right? So we center at x not equal to 0, or if you're the book, c equals to 0, right? Okay. So what we got here is we've got x cubed times the cosine of 3x, right? Plus x to the 10th times the cosine of 3x. But I tell you, I'm going to write that one last because I want to emphasize something here. What can you say about these two things I just wrote? I know these are going to go together because those are both odd functions. So they're going to give me an odd series. The last one is an even function. That's an even function. These are both odd functions.
Is it because the x cubed is odd and the sine's even?
Uh-huh. Yep. That is true. The product of odd and even is odd. Okay, so function-wise anyway. Not for numbers, right? Product of odd and even number is what? 2 times 3. 6. It's even, isn't it? Yet the product of an even and odd function is what? It's odd, yeah. So be careful with these words. They mean different things in different contexts. Contexts? That doesn't seem like a word. All right, so x cubed, a questionable word at best. Let's hear sum n equals 0 to infinity minus 1 to the n divided by 2n factorial, parentheses, on the parentheses are important. And then we've got 3x to the 2n. How do I know that? Because I know the power series for cosine, right? And then I've got my sine, sum n equals 0 to infinity minus 1 to the n divided by 2n plus 1 factorial. And I'll go ahead and rewrite this as, well, fine, 7x to the 2n plus 1. All right. Then I've got plus x to the 10th times the sum n equals 0 to infinity, minus 1 to the n divided by 2n factorial 3x raised to the 2n power. So all I've done so far is just use substitution into the known Maclaurin series for sine and cosine here, right? Which terms are not like the others? Which ones do not belong? If you think about that, the x cubed cosine 3x, what's its lowest order thing going to be? What's the power series for cosine? Mm-hmm. Right, so my point being, this term at lowest order is third order, right? The lowest order term in the power series expansion for x cubed cosine 3x is x cubed. So that starts competing to add together with this one at n equals to what? N equals to what? So these start over, let me say it this way, these overlap at n equals to, let me call this, well, this n, okay. What? 1, right. So I probably want to split off the n equals 0 term there because it's exceptional. Okay? So n equals 0, what do I get? What's the first term in the sine 7x? It's just 7x, okay? So then I've got 7x, and then I'm going to go ahead and simplify this a little bit. Plus the sum, n equals 0 to infinity, minus 1 to the n, 3 to the 2n, divided by 2n factorial, x to the what? X to the 2n plus 3. Then I've got plus the sum, n equals 1 to infinity, minus 1 to the n, 7 to the 2n plus 1, divided by 2n plus 1 factorial, x to the 2n plus 1. Plus this thing over here, which is, it's just going to be what it is, n equals 0 to infinity, minus 1 to the n, divided by 2n factorial, x to the, ooh, forgot my 3, 3 to the 2n, and then x to the 2n plus what? 2n plus 10.
So you just pull out the 7x so that you can
Yes, sir.
make it white.
Why is
You're
it
fine.
equals 3 instead of 2? I'm sorry.
Why is, what? Why is what?
Why is it x to the 2n plus 2, not just x to the 2n?
X to the 2n,
Get an x cubed out.
it's this x cubed.
No, down.
Why is that just 3?
No, next to it. The x. Why is it 2n plus 3, not just 2n?
Because this multiplies to give us this 3 here. I mean, you're right. 3x to the 2n by itself is 3 to the 2n, x to the 2n. Totally agree. But we also have that x cubed outside, which we got to multiply in. Yes?
Where does this x
Where does the 7...
all the way to 11?
This one?
No, the first term.
That's the n equals 0 term. Now the reason I'm doing that is so that I can make the following substitution. So we'll let, let's say 2n plus 3 equals to 2j plus 1. And over here, we'll let 2n plus 1 equal to 2j plus 1. In other words, we're going to let n equals to j on this term, and we're going to let, let's see here, 2n equals to 2j minus 2. In other words, n is equal to j minus 1 for this one. All right, with that substitution, we get the following: 7x plus the sum. Now, if how do I? Sorry, if n equals 0, j equals what? J equals 1, right? J equals 1 to infinity here. And then, so I've got minus 1 to the j minus 1, 3 to the 2, 2 times j minus 1, right? Divided by 2n, which is 2 times 2j minus 2, right? Factorial. 2n is 2j minus 2, right? I think I've done everything there. And that's from this term. And the other one just gives me plus minus 1 to the j, 7 to the 2j plus 1, divided by 2j plus 1 factorial, close parentheses, x to the 2j plus 1, plus this thing over here I didn't change. And so there you go. That would be the power series centered at 0 for this function. Now, some people would find the last series distasteful. I mean, some people might insist on re-indexing that so it looks like... I would understand instructors who wanted you to instead have this, to introduce like a k and put like 2k equals to 2n plus 10. You know, if you did that, you'd have n is equal to k minus 5, right? And so you could rewrite that last thing as like the sum minus 1 to the k minus 5, 3 to the 2k minus 10, divided by 2k minus 10 factorial x to the 2k. And where would k range over?
5.
Right, 5 to infinity. So we could repackage this piece like that if we wanted to put it in sort of a more standard form. Does that help, Josh? I mean, you were kind of asking me about this earlier.
Yeah, the 7x to the left, that's helping me understand it a lot more.
Yeah.
Um,
I gotta peel off that 7x because it doesn't fit with this general pattern. Yeah.
That helps me out a lot.
Yeah. Anyway, tomorrow. Hey, by the way, what'd I say last Friday? Last Friday I called it, didn't I? That's right. Gotta give credit where credit's due. I understand. I knew and the thing is, I know if it's going to be canceled, it's going to be canceled on the day it happens. It's like, how can we be maximally annoying? But anyway.
Cancel class.
I don't have any kind of inside information. I made that cancellation.